This is the mission 48, and today we will have the presentation of Girinath, okay, uh, Girinath Anandham, about how would be the operation of the main station in Mars space. Girinath Anandham, you are welcome to share your presentation.
So, hello everyone. Before going further into my presentation, I would like to thank Professor Julio for giving this amazing opportunity. So, coming to mission 48, we can see the protocol of space habitants on my slide. So, going further into my presentation. So, today I'm going to present about main station facility. So myself, I'm Girinath Anandham. I study bachelor's in mechatronics at Anandham University of Technology. So today's agenda is going to be about design and infrastructure. So I will be talking about the quantity and the responsibilities of positions, necessary resources for 1 week if we get isolated, and resources possible for to generate insight and or like transported from Earth. So necessary machines and technologies in the facility. The guidelines will be provided and provided to the other facilities and the facility which we are working on for the Earth as well. So we'll be having protocols for safety, entertainment, food production, and 3D printing as well. So going to the main slides. So the main facility design. So the design and infrastructure of the facility, we are choosing a master structure, which is a 3D printed prototype. We will be having two Terra or airlock structures which is connected with each other. It uses a biopolymer composite which outperform the NASA strength, durability, and thrust testing. We just want to make sure that we have enough space for like working laboratories and resting and storage facilities. Moreover, I chose this structure because considering the time factor, sustainability, and shielding, it's so quick and more sustainable and more productive as well. So going further, the main reason to choose this structure is designed in PLA basalt fiber, which can also be extracted and processed in Mars, even if neither more any kind of extensions or like more structures. Each level has one window, which together gives a 360-degree view. So it has like direct natural light from waterfall skylight and then ground floor interiors, while to safe from harmful radiation. So we will be having 4 levels in each structure. It consists of outer and inner shell to protect the crew. Also, the crew will be having the access to rover, which will be like docked along with the facility. So our main functions of the facility, we just want to make sure we are maintaining a proper communication with other facilities at Earth Station all around the day and night. As we are the main facility, we just want to make sure we are having the proper communications. We are working on the protocols such as conducting experiments, repairing the components, or managing the disinfected environment, uh, maintaining the disinfected environment, monitoring the weather conditions by extracting data from the orbiter, updating facilities for preventive measures, and we will be also collecting progress of the research work from other stations using the data for future improvisations. So we will be also assisting other facilities to video conference on site. We will require crew members during extraordinary scenario. Make sure that all the habitants are safe during the isolation period and provide them declarations. We also make sure the crew knows their rights and maintain smooth relations toward the mission. We also monitor the research facilities every day by a rover vehicle or a drone. We also create 3D structures which are highly on demand, also managing the space at storage facilities. So the main facility positions, we will be having one main coordinating chief, one mechanical engineer, automations and control engineer, electrical engineer, space medicine and psychology expert, and the informatic engineer, design engineer like architect and civil engineers. We will be having one chemical engineer and a few assistant engineers, 4 to 5 members. One with mechatronics specialization who knows more about photonics and optics, which will be used for signal processing and all this kind of communication stuff. And the others it will be like with, biotechnology. One will be with metrology and communications, and one will be for monitoring the facilities and about technology engineer. The duties of the position. The main duty of the coordinating chief is responsible for managing the astronaut office resources and crew assignments for the future research. Also coordinates the whole crew and maintains excitement and motivation for the whole crew. So mechanical engineers, the main responsibility of the engineers is to design, repair, assemble or disassemble the machines in the facility. So automation and control is responsible for any computer controlled machines, even stationary ones. They also for developing for advanced life support systems such as biological water processes, oxygen generation, and CO2 recovery systems. Uh, Otherwise, like electrical engineers and electronics are the role is to assist the crew in electrics and electronics by helping them to come with more compact and safe electrical solutions in the whole facility. Space medicine psychologist is responsible for doing research and creating advanced medical systems, and also takes care of the mental health of the astronauts in the facility and assist members who are in other facility as well. Informatics engineer is responsible for creating and dealing extraordinary situations in the facility where immediate help is required in recovering the drone or rovers in case of emergency situations. Design engineers are they are responsible for designing future facilities or come up with more sustainable solutions as well. And chemical engineers is responsible for analyzing minerals during research and also work for meteorologists whenever they're working in the market terrain or minerals. So the main station facility resources, when it's quarantine, it's for 1 week. So the necessary resources for 1 week is like water is produced as a byproduct from the fuel cells in the station. The process is complicated, but simply to put, fuel cells make electricity from hydrogen, oxygen combined. When atoms combine, it makes electricity, but also water as well. And the water can be used in the cabin pressure by the cabin pressure as well. The astronauts will be using allowed to use 20 liters, 20 gallons per day, and the minimum level of food requirement will be 830 grams on average for the whole day. Supplies will be exchanged in between the facilities according to the demands and priorities. So, and the resources which is required, like able to possible to generate inside or transported from Earth, that will be like produced using the MOXIE instrument, the technology which is used to produce a small amount of pure oxygen from Martian carbon dioxide. It's a process electrolysis process which was sent by recently by NASA's Perseverance mission. So we will be like having food for 1 year, but after that we have to generate our own food. Once we should make sure that we have our facilities built at the station. So the power, we will be using solar energy and nuclear energy. Nuclear energy can be used in habitats and for propellant in the launch station as well. So I'm just trying to show a small video about the flow power reactor which can be used in Mars.
We would need power on Mars for two primary reasons. The first is the astronauts need power for their habitat, so they need oxygen to purify water. But prior to their arrival, we need to make liquid oxygen and propellant so that they can get off the Martian surface. Kilopower is a small nuclear reactor concept that is very simple and uses a minimum number of parts in order to produce power. Power is the lifeblood of our exploration. The kilopower system we're testing now is enough to power many entities deep space missions to the outer planets, the moons, or Saturn, Jupiter, to meet and outpass Pluto. Kilopower is a result of lessons learned over the past decades of trying to get space reactors established. We went back and tried to make this system as simple as we could. It ranges in size from 1 kilowatt, about the power needed for, say, a household toaster, up to 10 kilowatts. And at 10 kilowatts, we would use 4 or 5 of them on Mars in order to make fuel and to produce power for the habitat. It has a solid metal block of fuel that we fission that produces heat. That heat is used to heat heat pipes, which are tubes full of sodium metal that we boil, and that delivers heat to what's known as the Stirling engine converter. The Stirling engine converter is a simple heat device that uses temperature differential to make electricity. NASA chose Los Alamos to do the nuclear reactor design because of a long history of doing this type of work going back to the 1950s and 60s. We also have some of the world's leading experts in space reactor design. In the future, we want to take kilopower to the next step. We want to test more of its reliability and its safety, and also do the types of tests NASA requires in order for a system to actually go into space.
Going for the next. So going for the next slide. So the guidelines provided to the other facilities of the world station is to maintain proper communication with the main station and update the status regularly, maintain cleanliness and hygiene throughout the facility, and also make regular check where there is possible for microbe infection, have a healthy relations with crewmates, and try to maintain professionalism in work environments, report the facility about your research and personal duties in a regular basis, keep your priorities and stay focused. And the routines in the facility is we have a regular maintenance or repairing sessions of components in the main station. We make communication checks with other facilities at station, weather report updates for other station or monitoring for possible threats, ensure sanitary measures and clean workstations. We also report the research activities, the activities to other stations and at station. So the possible activities, and we advise to have a healthy diet and healthy food in Earth, stay clean and maintain hygiene, try to sleep 7 to 8 hours a day for a fresh day, be in a regular contact with your doctor and maintain proper health checkups, try to participate in conference, webinars and networking events online, be kind to your family and loved ones or even strangers. Humanities first and everything says. The protocol for safety in the stations, maintain clean habits and frequently disinfect the workstations. In case of storm or harsh weathers, team members try to reduce the use of electric components. In case of small fire or explosions, try to turn off the electricity and follow the safety protocols. In case of emergency, inform the health center and get assistance from space medicine team in the main facility as well. And team members can isolate themselves in other cabins in case of isolation situation. Protocols for activity of occupancy or entertainment. Astronauts will be having a gym or sports equipment in the main facility station. It will capture energy and stores it as well for later for following the facility. Astronauts will be having onboard games, board game evenings once a week in order to boost up their minds. Internet use can be used to talk to their family, friends once in 2 weeks or so. Also, once in a month, they are allowed to watch games and cheer up their favorite sport teams. Protocols for micro production. Micro production facility will be only started if there is a need for food, as we have supplies for the food already from the greenhouse station. We will be also having a vertical aquaponics system. It will be maintained by biotechnology engineer and a chemical engineer with help of professionals in the greenhouse facility to video conferences. So protocols for 3D printing. 3D printer facilities will be used only if there's a high demand for it. Facility will also make sure that the quality and sustainability of the products are good. 3D printing and for the medical purposes can be done operationally as well. Most of the 3D parts can be 3D printed. So the 3D printer is considered as an essential device in the facility. We will be also having a backup 3D printer as it is in the main facility. So these are my references. Thank you. You can follow Habitat Marte on their socials. Yeah, we are done.